Hello everyone, this is Mr. BQ coming from my backyard. You can see my hair is getting all kind of crazy right now. Hope everybody is staying safe and able to keep up with these lessons. I hope you're enjoying them. This week we are moving on to kind of a catch-all chapter. We're going to be talking about cross sections, nets, rotational solids, and density. There's a couple quick lessons. This shouldn't be too bad. Hopefully you enjoy everything and have a great week. Hello everyone. This week we're going to talk about various topics. The first one up is density. We're going to look at density in a couple of different ways. The first thing is the density of an object, and this is something you've probably looked at before in science class. And the second one is population density. So the first thing is density of an object. So this is really the density of an object is its mass per volume. Mass per volume. And with density, one of the ways we'll look at this is like, does something float? If our mass is in grams and our volume is in cubic centimeters, grams per cubic centimeter. If the density is 1, that is the density of water. Anything with a density greater than 1 is going to sink. Anything with a density less than 1 is going to float. So really easy calculation. So let's take a look at a couple of examples. So we have two types of wood and want to see which one is denser. You have two logs with the following diameters and heights. Notice diameters, and we want to figure out the density. So the first thing we need to do is to figure out the volume. So volume of the fir. Well, volume of the fir, the formula is pi r squared h, as we did last week. So volume is pi, the radius is 3 squared, the height is 17 centimeters. So my volume of that log is 153 pi cubic centimeters. The volume of the redwood, we have pi, the radius is 4 squared times 12, they're all in centimeters, and that is going to be 192 pi cubic centimeters. Remember, cubic centimeters is the same as a milliliter if we're looking at liquid measures. Now we want to find the density. Well, for the fir, we have a mass of 254 grams. So we're going to do 254 over 153 pi. Now make sure when you plug it into your calculator you plug in the pi, and make sure that denominator is in parentheses, because if not you're going to get your calculations all messed up. So my density here is going to be 0.53, and that's grams per cubic centimeter. Now for the redwood, we've got 271 grams over our 192 pi, and that's going to give me a total of 0.45 grams per cubic centimeter. So the fir is denser than the redwood. Okay. And that's about it for density of an object. Pretty easy calculation. The next thing we're going to talk about is population density. And we've been talking about population density. It's how many people live in a certain area, how many animals live in a certain area. And it's more based on area versus volume, because we really don't measure area. During the crisis that we're in right now, we're hearing how many people who have been infected in a certain area. That's the density of people who've been infected. So it's very relevant to what we're going through right now. So population density is the population divided by area. Make sure you're careful with your units and write out the units correctly. So here's a real quick example. Arizona has 7.3 million people and about 114,000 square miles. What's the population density of Arizona? It was really straightforward. We're just going to do 7.3 million divided by 114,000. Plug that into our calculator and we get 64. What does that 64 represent? That's people per square mile. Right? And that's a pretty low population density for an entire state. But let's look at the city of Phoenix. City of Phoenix has 1.6 million people in 517 square miles. So in the city of Phoenix, 160,000 divided by 517 gives me a total of 3,095 people per square mile. So the city of Phoenix has a much higher density, as we expect, of people per square mile. And if you think about cities, most of our cities are laid out in a grid where the major streets are 1 mile apart. So if you think about going from Chandler to Ray, from say 48th to 40th, that would be a 1 mile square. And on average, you'd have about 3,100 people living in that area. Does that make sense? Think about it. So there's our lesson on density. Pretty quick and easy. Do the handout.